So, I will give you time to catch up. If you just got here, it's that. Yep, and there. Did you get the 415 too? Nick, did you get 415 too? Okay. So, on page 167, open that book. Shocker, right? We haven't used books all year. This would be one of the 2 textbooks that you would be carrying around if we wanted physical books.
No.
Which you still can have a physical book if you're going on a road trip or anything like that. But on page 167, you see 4 different, relationships, I guess we can say. And not relationship like Brangelina, right? But like a mathematical relationship relating like some figure number and maybe some graph. Or, hey guys, I'm going to give you like a little while to figure this out on your own. So if you could just listen to directions right now. Somebody at the back table, will you throw the door shut, please? Or I can come back. Or that. Thanks, Mason. So, for A, this tile representation works with this graph. These go together. Okay? For B, this graph is the only thing we're given. For C, I have a table and a tile representation.
Good afternoon, Phoenix. Please pardon the interruption. Winter sports open gyms and tryouts will be going on here in October. Many of the tryouts start by the week of the 24th, and some of the open gyms start today. If this is your first time leaving on the athletic shuttle, please keep in mind that you need to sign out on the clipboard in the 7th grade hallway before boarding the shuttle. Also, just please make sure that you're prompt. The shuttle does leave pretty quickly so it can get to the destinations in time. So please make sure to leave promptly at the end of 3B if you are going on the sports shuttle.
Get married. It gives you a
Alex
fidget.
Wright, please stop by the office. Alex Wright, please stop by the office. Thank you.
I hate afternoon announcements. And D, yes.
I actually have a question.
Yes.
Sports shuttle. So
Yes.
I'm going on it today. So, how quick does it leave?
Quick. Don't change here. Don't do anything else. Sign out, get what you need, go to the shuttle spot. Because I cannot, I can't really speak to each shuttle and how quickly it leaves. Talk to that bus driver, talk to other people. But, really, these are new routes for the new sports season. So, I don't know. But all I know is they leave quickly. So, guys, if you know your friends, got to get to sports shuttle, help them out if you can. Right? If you know you're hanging out for extensions and they're going to sports shuttle and, they're freaking out about something, try to help them out when you can. Yes?
I know winter sports wrestling is a winter sport, but I don't know if my forms are filled out and I don't know if I'm going today.
Yeah.
Can I check by the office?
Yeah, you can go right now if you really... Well, wait 30 seconds so I can finish these directions, then go.
I don't know if that's
And D gives you the equation that actually we're going to try to derive for all of these other ones. But D gives you the equation and what that corresponding graph is. So here is your task. Using your graph paper and those beautiful XY tables that you've made that I will come around and be oh so impressed at, you're going to fill in X being your figure number, which is why for most of these, it just makes sense that we can start at figure 0. Because that's where, even though we don't normally look at figure 0, we can hypothesize what it might look like. I really doubt we're going to go into negatives, right, for the x's. So remember, x is figure number, and y is what? Yeah, the amount of tiles that it would have. Really, we can start to call it just the output. But yeah, y for us, as we've been talking about, is the tiles in the pattern at that figure. Any questions on what we're doing? We're trying to create 4 tables filled in with the information based off of here. Then, once you have your 4 tables all filled in, you're going to try to derive the y equals equation. Obviously, D is done for you. The y equals equation for each of these different situations. Any questions? All right, you're going to want to collaborate here because more brains are better than less brains. When you're done with all 4 of these, you may spend time working on homework, but not instead of, right? It's not like, oh, we'll go over these together. I'm just going to do my homework right now. Not an option. Okay, do these, then you can spend time on your homework. And then I'll open up the Desmos here in a little bit once we're probably in the same spot. And then you guys can choose Desmos or homework. Yes, so yeah, if you need to go check on sports or whatever, or call parents or double check stuff, go do that.
That's the E word.
Whoa.
I said easy. He said at the end.
Oh, you said the E word.
All right, well, makes it okay.
So if I say the F word and then say
Can I change it to like sports stuff?
Random.
Or should I?
If you really think you need to right now.
Very necessary.
I just don't know if I'm gonna have time before the best.
You can go now if you want. That's fine.
Okay, I'll just take like 1 second. I just need to change.
Hey, Zach, join me in the hallway. Join me in the hall.
Okay, let's see.
So we have what's 3 minus? 3 at Hey, wait. Dang it, if it's 52, it wasn't so much
Zach's going to take a couple minutes to think about appropriate decision making, so he's just chilling over in that classroom. All right, let's go over at least one to make sure that we are on the right path. And of course, you know what I'm going to use.
hard.
I mean, it's not even random, like algebra tiles. See, that was an appropriate joke. So, what can you tell me where to put something? Did Bradley leave? Am I just blind now? Okay. Yeah. So, Bryson not here today. Yeah, I didn't think I saw him. I have Bryson's water bottle, by the way, if he shows up from. Mason, what does the first thing up there tell me?
First one, that there is 13.
Yeah, 9, 10, 11, 12, 13. 13 tiles in what? What is this telling us? Figure 3. So when the x is 3, our y is 13. Or if I had it vertically. So then, the graph. Colin, what is the graph telling us? What do you mean? I'm confused. What do you mean? Say more. Yeah. Quit selecting. I just want to make a line. Or Colin, I mean, you're welcome to pass, but like I don't know. What is this graph? What's the 3 and the 1 and like? Annabelle, can you help me out with what this graph is telling us? So, last try, then I'll take hands.
So it's basically the graph is telling us that. So basically, it's saying 0 is 4 because the line intersects right with 0.
Ooh, now if we trust that it looks like it's at 4, okay, what else can I glean from this graph? Though you can keep going, so.
So you can tell what x is and what y.
Okay, well, when x is 1, actually, I don't quite know what that y. Like, we could guess, but I'm not 100%. You want to pass it off, or you want to keep trying? I need to use this 3 and this 1. Okay, so you want to pass it off? Caden, it's like we're playing hot potato here.
So, the 3 and the 1 shows that every time the figure number goes up by 1, the amount of tiles goes up by 6.
Oh, this is delta x. This is the change in x, and this is our delta y. That tells us, as Caden said, every time we go up by 1x, we go up by 3 y's, meaning this must be 16. Make sure you've got the rest of this table filled in to agree with this and keep going. All right, keep going.
Okay, so we're gonna take this one out and
Okay, let's do this.
line like that line.
I know C.
Hey, what's the first line? Yeah, it's just moving. There's no C. I just know that I have to see my headphones today.
So this is like it's 8 figures in the same piece. And then 30.
Yes, I know.
Love that.
That I feel.
If you want to verify your table, you can look up here. If you don't want help, don't look up here. Ding, ding, ding. We verify what Soph said. Yeah, that's A, right? That is A if you want to verify your table. Now, from this table, we can actually derive the entire equation of the line. Now, we've started to figure this out through Desmos. Hey, Liam, it's really obvious you're not on task when the calculator's upside down. So we've started to derive this through Desmos, but not all of us have probably figured it out. But this key point, and then any other, because it's a not proportional, it's a linear relationship. So Val, have you figured this out yet? It's okay if you haven't, because we've just played with it in Desmos a little bit. Have you figured out how to get to the equation, like the y equals? And it's okay if you haven't.
I do whatever zero the y at the zero figure is.
Okay.
Use and then minus whatever that was from the y number for the next one and find it from that.
So this, which also we kind of saw from our graph, so that was what?
+3.
So that's a +3 that also our graph told us up here. So can I throw it to somebody else? Because that was perfect. Yeah? Can I throw it to somebody else? Or you want to keep going, Val?
Keep going.
Okay, you want to keep... All right, keep going.
Or wait, no, I meant...
Throw it to somebody else. All right, Liam, can you tell me what we do with that? +3 and whatever else?
Yeah, it's like +3 repeated for each time.
Okay, so when I go to write it as the equation.
Y equals x +3.
That's +3. You're really, really close.
My brain is not working.
You're good. Do you want to pass it? Zach? No? All right, now we'll take hands. Bradley? 3x, because the 3 happens multiple times, right? Something that happens multiple times gets multiplied, but then we still have...
But why are we multiplying? Why are we...
So just hang on, okay? Then we still have the +4 of where we started. So if we take this back to the beginning, what this actually tells us is what this would look like is 4 tiles no matter what. 4 tiles even when the figure number is 0. And then every new figure number, when we would see that growth, like we did last week as what changed, would have 3 more tiles than before. So if I want to jump right to, I don't know, what would figure 100? How many tiles would figure 100 have? Well, how many, anybody?
304.
304. I'm not taking questions right now. Keep going on B, C, or D. I'm going to walk around, but I'm not taking whole group questions right now. We're playing with it. We're discovering it. Okay, I'm not taking whole group questions. I'll come take your question. So that's what we have to stop doing with the guess and check. We have to actually use the info in front of us to derive the info that we need. So the first thing we wrote right now is that figure 3 had 13. Right? That was 4, but we didn't have it. Right? So the only thing we had at first was 3 and 13. Okay? But then when we looked here, we had a y change of 3 for an x change of 1. which will happen every single time x changes by 1. Y will go up by 3.
What's the difference?
X goes up by 1.5. Y goes up by 3. If x goes down by 1, then we come back down the x-axis. Then we would go down by 3, which is what we did to work our way back to. And this tells us figure 0 has 4 tiles, and then every time we move on to the new figure, we add 3 more tiles. Because every time x changes, for every x that we have 3 extra tiles. I'm going to draw it over here. Hey, do B. Do B, do C, they all tie together. Trust me. Maybe. Maybe. So just hang on. I got to see if we'll even get to C. Bro, that's not like up to me. Alright, guys, check it. If we were visualizing this, because we're still trying to tie all this together. If we were visualizing this, your figure 0 having 4 tiles, if I were to choose a piece of this that has 4 tiles to keep, I'd probably choose the little tail of 4. Right? So figure 0, quote unquote, figure 0, would have just those 4. Yes, my tiles are beautifully not the same.
They're all different, guys.
Yeah, just like us.
Apologies.
So then, figure 1 added 3 tiles, right? Figure 1 added 3 tiles, like we said. So we add, nope, that's 4. Math is hard. We add 3 tiles, and there's figure 1. We add 3 tiles, and there's figure 2. Right? We add 3 tiles, and there's figure 3 that they gave us to start with. If I want to figure out figure 100, that would be really annoying to draw. So the reason we start to incorporate these y equals equations is to determine how much we would need, like what y is, for any figure number. Like, how many candy bars do I need to buy to do s'mores with all of the 7th grade? Or how many marshmallows? Or how many graham crackers? Like, guys, this is literally what everything in life comes back to, is relationships. Of how many do I need per this? What extra do I need? So guys, if we were saying 3 marshmallows per student and 4 extra mallows from me. Alright, that's what this situation could say. 3 mallows per student, 4 extra because, you know, I want some. So, in a situation like B, they can buy their own mallows. No, I'm joking. So, in a situation like B, they now give us, oh, crap. This table's not going to be big enough. I can make my vertical table big enough if I, like, add some onto the bottom. So, guys, your table here for B needs to go to 7 at least. If your table didn't go to 7, extend it. Who, what? Sweet. Yeah, as long as you go all the way to 7, that's pretty good. Alright, so still random cards so you can help me out. Leah, what would you suggest that I fill in the table? Can you give me like 2 or 3 or 4 things to throw in here?
So from 7.
Hey guys, there are like 5 of us having a conversation. We're going to try to do this real quick together and see if it's starting to make sense.
7, you can see the line going up and it's 58.
So 7 gets 58. Is there anything else we can fill in?
Yeah, and 4 is 31.
4 gets 31. Do you know what to do after that? Do you know what to do after that, Leah?
I think. I don't know.
Do you want to give it a shot? You can give it a shot, or you can pass it off to somebody else.
Can I just pass it off?
Sure. Sure, we'll take hands on this. Ren, what are you thinking?
So what I did was I subtracted 58 from 31 to get 27, and then I looked at the spaces between 4 and 4 and 7 to find that you have to divide it by 3, and then you get the how much you averaged.
Absolutely. Put that on your paper. If you choose not to, that's up to you. But remember, most of these things are becoming reference pages as we head towards our next mastery, which, as you can notice, if you look at the week, is probably coming on Monday, right? If we're playing Jenga on Friday, if we're doing closure, like our next mastery is probably coming on Monday. Delta Y is how we say this, and that's because that is the Greek letter delta. It's just a triangle. But delta Y is Y2 minus Y1. Delta X is X2 minus X1. And it actually doesn't matter which one of these is your 2 and which one of these is your 1, as long as we do the subtraction in the same order. So what Rin said to do is 58 minus 31, and 7 minus 4, which really got Rin, what was 58 minus 31?
That was 27.
27. Oh, that one I can do. 3. What's 27 divided by 3?
9.
So what Rin really just said was this is 27. This is 3. But what that means is if I break it down to just the little jump to get there, that's going to be 9 over 1. And yeah, the 9 looks smaller because they scaled the y-axis differently. So if we keep going up, no, make sure you're with me. If we keep going up, we'll keep doing this same pattern multiple times. So since that's going to happen multiple times, it is what we... Anybody?
No, that is true.
Is it going to add or going to multiply?
Oh.
It's going to multiply because it's going to happen multiple times. So when we go to write our equation, we're going to use that 9. Can anyone tell me the y equals here? Now, we might not know how to... Actually, we don't know how to get it yet. We don't have enough information yet. If I go 9 up every time I go up, what do I do when I go down?
Minus 9.
Anybody? Yeah, we can minus 9 to go backwards. So let's minus some 9s. What's 31 minus 9?
22.
22 minus 9?
13.
13 minus 9?
4.
Wait.
Negative
4.
5.
So apparently, this would have negative... Well, guys,
Negative tiles?
is there really a figure 0? This gets deeper into, like, math, like the connections side of math. Is there a year... Actually, this relates to social studies. Is there a year 0?
No.
No, there actually isn't. Like, funny enough, in the timeline. But if we plant a seed today, which literally I planted some grass yesterday. If we plant a seed today, it is day 0. Because 0 time has elapsed, right? Because what we're counting is how much time has elapsed. So if I plant my seed 5 inches deep, could it be at -5 when it starts?
Yeah.
And then if I'm going to gauge how tall my tree is, which actually, if no one's talked about this, tree term is coming. Stay tuned for that. All right, so my plant starts at -5. It grows 9 every whatever X is. Could be weeks, could be months, could be days,
Could be years.
could be years.
No,
My
we
equation.
58
Hold up.
years.
Can anyone tell me what my y equals equation becomes? Crap, this is a lot of hand. Isaac, you got your hand up almost this entire problem. 9 times x, because it happens multiple times, plus -5, because that's where we started. Questions?
Oh, yeah.
bias question? If you remember, so
Wait, never mind. I completely forgot. It was on my closure.
so we will do closure on Thursday. If you don't get it done in class, it might be homework to finish. If that's what you're wondering, because like stuff that's written over there, that's just my goal right now. But I think we'll probably be able to make that for the goal for this week. Isaac? Yeah, you can write -5. I just don't like minus. It's just a bias of mine, right? So here we had figure 8. Ooh, we also have figure 3. So make sure your teammates and you agree. If you haven't done this, do it. Should we start to make more sense? Of why we multiply with what we multiply with? Okay, what's your different question? That -5 only happens here at the very beginning. That's the only place we see that -5. The constant is only found at the very beginning. Then we move on from it, like never be seen again. Because like, when does the -5 matter to my plant? Only the day that I plant it. Then it starts growing from there, and what I care is how tall it actually is.
The -5 is in the equation to get to the start.
It is where we had started from. Like,
Because you don't multiply it.
correct. It is added. It only happens.
Okay, so you know that the difference.
I understand. So,
You are alone.
So 3 is 12, and 8 is 2. So there's like 5 spaces between them. So if they're 10 away. So 2 and 12,
Vertical tables can be extended a bit easier, so I kind of like
2 and 12 are
verticals.
10 away. So you have 10 divided by the spaces between each of the figures.
but 2 plus 2 is equal
So what do you think that is?
That sounds like a great proof for a different class. Especially not when it's trying to accelerate through 2 textbooks. Right? So I took my x's up to 8 because one of the x's they give us is 8. Sam, would you like to help me? We only have about 3 minutes left, so I think I'm going to write up here just to make sure that I write the right stuff. You're welcome to hop up here and ask questions like you're me, but I'm going to write. Right, you can narrate, but I'm going to
Wait,
write.
yeah.
So we know that
You got to speak up real loud.
we know that the figure number is 3 and the number of tiles is 12. But then when we get to figure 8, we have 2 tiles. Why is that? Mason. Because it subtracts by 2 every time.
Well, we don't know that yet.
Well, not yet, but you are correct.
How could you derive? Sorry, you can ask the questions.
So, basically, I just looked from where I had a suspicion because of the point where figure 8 was less than figure 3, which normally that would not make sense for our pattern of what we are doing right now.
There we go. Alright, so Sam said, first things first, you notice this isn't normal for what we've been doing. You should expect that. The longer you work with CPM. Hey, Val and Isaac, can I help you guys?
Yeah, we're trying to find my dad's number.
Yeah, it's not up yet, because we're not done with this yet. So go ahead and put your computers away. Thank you. So, what is our change here? Sam identified it was?
The figure number 3 is less than 4.
Yeah, but then give me specifics.
Delta
What?
X is less than 4.
Ooh, so delta, the change from 12 to 2 is 10, but negative, right? So your delta y is -10. What's your delta x? Not negative. This is +5. Right? If we go down 10, we're actually going +5. What's -10 divided by 5? -2, which makes our equation y equals
5x plus -2.
other way around. negative 2x plus... I gotta figure out what this is gonna be. If I was going down by 2, like 10, 8, 6, I gotta add 2 going up. So I think it's plus 18.
Wait, I have a question now.
Yes, we have 2 minutes to do D. Who told you guys to pack up? Yeah, if you packed up, get it back out. I mean, unless you've got D totally done and you're just like, oh, I'm done, I'm confident, we're all good here.
Oh yeah.
Oh yeah, me and Jen finished.
All right, so you can fill in the table for me then.
Yeah.
All right, Val, help me out then. Val says he's like real good at this already. Which the more we practice, the better we get. Val, as I start filling in my table, what would help me out?
0 would be 7, since that's where it is on the graph. And then it says minus it. If you go over 1 and it says minus 3, therefore the next would be 4.
Okay.
And then 1, and then negative 2,
Ooh.
and then negative 5.
Wait, we're getting negative output values?
Yes.
Can we have negative tiles? Like, oh wait. Wait, what? Here, think about that again.
What was the word you said about?
So, is every situation like this figures and tiles? No! This could be anything! So this is where we start to like have to retrain our brain or like just go ahead and stop. Like this is the input and this is the output. It's not figure and tiles, it's input and output. Can my output be negative? Yeah. Like what? I don't know what the output is, but it can be negative. Isaac? So then, well, they gave it to us here, right? So this one, they did give us the equation, but this shows us the minus 3 is happening each. Guys, here's what you should have in your notes. Over by your table, and this is why, like I told you, if you put your stuff away, get it back out. At your table, what we should look at, I was trying to decide whether to say C or what word. What we look at is that every time the X goes up by 1, right, and show like a little plus 1. This is going down by 3, and because that happens multiple times, that is the multiplier. Where we start at is where we start at. Quite literally, where we start at is where we start at. That's it. Have a great day. Yeah, those are our homeworks for the week. If you want the next homework or all of them, like just come see me. I'll give you the future homeworks. Totally fine.
I found that it's really easy to think.
Whoa!
It's easier to think of it like these things instead of just like thinking of them as tiles. You can think of them as like money. Like for